In this video, we're going to look at measures of center and position. We're going to look at the vocabulary and the formulas needed to make some calculations and also look at some examples. So before we begin, I want to go over a symbol that I'm going to write over to the side and make sure you understand what this means. This is a capital letter sigma in the Greek alphabet, and in math, this stands for the sum. So if I have the sum of the values a sub n, where n equals 1 to 10, we could find the values, the total sum of those values. Now this is a notation that we won't really see. We see it more in terms of just referring to using and finding sums and formulas, but literally in the first word we're going to look at, we're going to need to use the sum, and so I wanted to make sure that you knew what that symbol meant. So when we look at data, there's several things that we can calculate. We can calculate measures of center, we can calculate measures of spread, we can calculate standard deviation. There's a lot of different things that we can calculate. And so we're first going to start looking at measures of center. The first measure of center we're going to address is the mean. This is probably the one you're most familiar with. Now, when we're talking about statistics and we're talking about a sample of a population, we call the mean X bar, or just the mean. Okay, so this is my symbol that represents mean. It's referred to as the arithmetic mean, T-H-M-E-T-I-C, arithmetic mean. And when people use the phrase average, this is the mean that they're talking about. This is the average that they're talking about. The way we find the mean is we take the sum of all of our x values and divide it by how many values there were. So we would write x bar equals the sum of the x values over n. Let's say I was going to look at the average quiz score for the first quiz in this class. What I would do is I would add up all of your quiz scores, and then I would take that number and I would divide it by how many test scores there were, and that would tell me what the average was. One of my classes that I took at TWU recently for personal enrichment, the professor, there was only 8 people in this graduate class. No, not even 6 people in this graduate level class. And the instructor would leave the statistics on, they use Canvas. So you could see, like, did I make the highest score? Did I make the lowest score? How was I above the average? Was I below the average? And so it was kind of funny because it was like, it wasn't a huge sample of people. It was only 6 of us. So you knew if I got the highest score and there was only 5 other tests, you could kind of suss out where everyone else in class. So anyway, sometimes instructors will share those kinds of measures of center with the class. The median is another kind of average. The median is our middle number in an ordered set. So I think that that's often forgotten. It's not just the middle number out of all the numbers that are listed. It's first you have to put them in order. And then you find out which number or numerical value is in the middle. So for the median, when you have an odd number of values in your set that you're looking at, there is an exact middle number. So for example, I'm going to just draw in the top, I'm going to say, okay, let's say I weighed my cats and one was 7 pounds, one was 8 pounds, and one was 14 pounds. So there are 3 values of their weights. And so I can say, okay, well, let's cross off the ends and we have our middle value. All right, so our middle value is 8. The median in this set is 8. But let's say we were looking at 4 students' test scores, and somebody had a 62, and then a 71, and then a 97, and then an 84. Well, first off, I need to put them in order. So I need to switch 97 and 84 because my list must be in order. And so then, but now I have an even number of values in my set, and so there is not an exact middle number there. So what we do is we cross off the values one by one, and then when we get two left in the middle, we find the average of those two. So we would take 71 plus 84 and then divide by 2. That gives me 155. 155 divided by 2 would be 77.5. Check me on that. But anyway, so middle number in an ordered set, if it's odd, it is the middle number, mid-num. If it's an even number, it's the average of the two in the middle. Okay, so median is a very important measure of center. The median value of a set tells you that half of the set is larger than that number and half of the set is smaller than that number. And this is why this is important. With the median is not swayed by what's called an outlier. So let's say, let me give an example. Let's say we surveyed 10 cashiers at Target and asked them how much they were making per hour. That's a rude question, but let's say that that's what we were asking them. So we have somebody says $9, somebody says $10, another person says $10, another person says $10, another person says $11, another person says $12.50, and then somebody who's been working there, let's say for 25 years as a cashier, and they make $50 an hour. Now, I know that that's not maybe necessarily realistic, but it's going to get our point across because here's what happens. If I were to find the mean of these hourly wages, this $50 here on the end would pull the average, the mean, up significantly. So let me calculate it. When you find the average of these hourly wages, it's over $16. But oh, look, out of these 7 people, only one person makes over $12.50. So the average in that case is being significantly impacted by this very large number. And so the mean we call, it's non-resistant. So it's easily swayed by outliers, either outliers that are too big or also outliers that are too small. So outliers can skew our data one way or the other. And so in this case, the mean is impacted by outliers. But if you think about it, looking at the median, our middle number in this ordered list, is 10. So that outlier doesn't pull the median one way or the other. The median tells us that half of the values are less than 10 and half of the values are greater than 10. Okay, so the median is really cool because it's resistant to outliers. All right, that's just my aside. The next measure of center we're going to look at is mode. It's our value that shows up the most often. Okay, so it's repeated in the set the most number of times. So looking at my salary example, we have 9, 10, 10, 10, 11, 12, 50, and 50. 10 shows up 3 times, so 10 would be our mode. Every other number only shows up once. Now, here's some things that you should note about modes. You can have more than one. You can have exactly one, or you can have no mode. So, an example where you would have no mode is if every value showed up the exact same number of times. So let's say we polled students their heights and we got 5'4", 5'4", 5'6", 5'6", 8, 5'8", 5'11", 5'11". And so every value for these students that we polled, we got the same numbers twice. So every value showed up twice. In that case, there's no mode because nothing shows up most often because they all show up the same number of times. In the example that we have up here, there was one mode because there was one value that showed up 3 times or more times than every other value. But we could have a situation where we have more than one mode. So let me write a sample on the top that shows us that. Let's say we had polled people and asked them how many hours of TV do you watch in a week? And these were our responses: 3 hours, 7 hours, 9 hours, 9 hours, 13 hours, 15 hours, 15 hours, and 17 hours. That's a lot of TV time, I think. But okay, so let's think about the modes. 3 shows up once, 7 shows up once, 9 shows up 2 times, 13 shows up once, 15 shows up 2 times, and 17 shows up once. And so therefore there are 2 values that show up more than the other values, and they show up the same number of times 2 times. So this is a case where we would have 2 modes. Our modes would be 9 and 15. Okay, and then lastly, for our terminology, for measures of center, our last measure of center we're going to look at right now is our mid-range. And the way we find our mid-range is you take the highest number in your set plus the lowest number in your set and then divide by 2. It essentially tells you what number is exactly between the highest number in your set and the lowest number in your set. So if the highest number in your set were 17 and the lowest number in your set were 3, then you would add those together. 17 plus 3 is 20. 20 divided by 2 is 10. So the mid-range for this example up top would be 10. I'm going to work through some examples. First, we're going to find the mean, median, mode, and mid-range for each of these data sets. Now, I'm not going to do all of them. I'm probably going to do maybe every other one, A, C, and E. And so if you want to do B, D, and F on your own, and there it looks like there's a G, but it got cut off, please feel free to do so. I'm actually going to start by taking each set that I'm going to look at, and I'm going to rewrite them in order from least to greatest. So for set A, I have 91, 95, 99, 97, 95, so I need to rearrange that. 91, 95, 95, 97, and 99. Okay, so again, the reason why that's going to be important is because when I'm looking for my median, my set needs to be in order. So it's a good first step, no matter what you're looking for first, to put those values in order. I'm going to do the same thing for set C and set D. Okay, so now that they're in order, I can start solving and figuring out mean, median, mode, and mid-range. So mean, we add up all the values and then we divide by how many there are. So in this case, we would add up 91 plus 95 plus 95 plus 97 plus 99. And there were 1, 2, 3, 4, 5 values. So I would take my answers to that and divide by 5. When I sum these values together, I get 477, and then you divide that by how many there are. There are 5, and that gives us 95.4 is our mean. Okay, our median in this problem, I'm going to cross off the n values. My median is 95. My mode is the number that shows up most often. 91 shows up once, 95 shows up twice, 97 shows up once, 99 shows up once. So the number that shows up most often is 95. And then lastly, the mid-range would be we take the lowest number plus the biggest number, so 91 plus 99, which gives us 190, and then we divide that by 2. 190 divided by 2 is 95. When we see that the median and the mean are very close to one another, that's oftentimes an indication that there's not an outlier. I'm going to solve the problem C and problem E on my own, I suggest that you pause and do the same thing and then check your answers with mine. So go ahead and check your answer for each of these. One thing that I want to point out is that in the example E, we have two modes. We had 75 and we had 82. In example E, we also have a repeating decimal. So when you do 54 plus 75 plus 75 plus 82 plus 82 plus 93, and then you divide it by 6, you end up getting 76.83 repeating. The way we represent repeating decimals is we put a bar over the part that repeats. So since it's 76.83333333, the only one that's repeating is the 3, so the bar goes over the 3. Now, another thing to point out is that in this first example, we had our in, or the number of data values, was 5, so it was odd. In this one, for letter C, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. Our in, or number of our sample, is 9. But in part E, example E, our in value was even. We had an in value of 6. And so when we find our median for a even set, we have two numbers that are in the middle, and we have to find the average of those two. So you sum 75 plus 82, divide that by 2, and that gives you your median. So hopefully that makes sense. In the next video, we will go into more details. Please make sure that you are taking good notes, and if you have any questions, please email me. Thank you so much.